We are solving a question that was given in NEET 2021 from the chapter Ray Optics. See what the question is. Find the value of the angle of emergence from the prism. Refractive index of the glass is given like √3. As this angle is given like 90 degree and this angle is 60. First thing here, angle is 30 degree because total angle in a triangle is 180 degree, which is the angle of the prism. So the first thing that what we understood is angle of prism is 30 degree. Further, what you can notice is this light ray is striking the surface normally. Angle of incidence is the angle with the normal. So angle of incidence equal to 0. As the angle of incidence is 0, angle of refraction inside the prism R1 is also 0 because it is striking straight, it comes out straight. So what is known to is I1 is 0, R1 is also 0. After striking this surface, here is a normal. It will deviate it from its path. It is moving from denser medium to rarer medium. Prism is a denser medium, air is a rarer medium. So when it is moving from denser to rarer, it moves away from the normal. It goes this way. Then this angle of emergence is how much? That's the question that's being asked. So we can further say angle of the prism is proved as R1 plus R2, that is 30, but R1 is 0, so R2 is 30 degree. If R2 is 30 degree, angle of emergence is how much is the question, right? Let me draw the diagram to you once again, diagram for you once again. Yeah, this is the prism. This is the incident light. As I told, with the normal the incident light is making 0 angle. So that was little not sufficient place to draw, so I will draw here. Yeah, angle of incidence I1, automatically angle of emergence inside the prism is equal to 0. After striking the surface, this is the normal. This angle could be called R2. As I told, it moves away from the normal. This is called angle of emergence. Now, at this surface, at this interface, I can apply Snell's law. What is that Snell's law tells you is, mu2 by mu1 equal to sin I by sin R. I will just draw a diagram for you to understand what's the meaning of that is. If a light ray is moving from medium 1 to medium 2, if this is the incident light ray, this is the normal, this is angle of incidence, extended normal, this is angle of refraction R. Then in this case, refractive index of the medium to where it is going with respect to from where it is coming is sin angle of incidence of first medium by sin angle of refraction of the second medium. Let's apply the same here in this case. Mu2 means to where it is going to air. So mu air by mu1 means from where it is coming, that is coming from glass, mu prism or mu glass. Sin angle of incidence means angle of incidence from where it is coming. Here the angle of incidence here is R2 by sin angle of emergence is sin A. Now mu air equal to 1, mu glass is given to you in the problem as √3, R2 is already given as found as 30, sin 30 by sin E we have to find out. So sin E equal to √3 into sin 30, but sin 30 is 1 by 2, so sin E is √3 by 2, that implies angle of emergence is 60 degree. Sin is √3 by 2 for an angle of 60 degree. That's the answer for the problem. So this is a very basic concept. You only need to know the Snell's law and how do we apply the Snell's law, right? Sine angle of incidence in the first medium to the sine angle of refraction of the second medium is angle of refractive index of second medium with respect to first medium. Once if we have the clarity of basics of Snell's law, we can easily solve that problem, right. Now let us solve the other problem also. This problem, this was given in NEET October 2020. It says, if the critical angle for the total internal reflection from medium to vacuum is 45. What is critical angle? So what we can say, what is the critical angle is? When a light ray is moving from denser medium to rarer medium, this is the incident light ray, this is an angle of incidence. For a particular angle of incidence called critical angle, light ray grazes the boundary that is separating the media, goes like this, such that angle of refraction is 90 degree. That particular angle is called as critical angle. We know at critical angle we have derived and explained it many times in the list, mu equal to 1 by sin c. But be clear what this mu is. It's actually mu denser by mu rarer, or mu denser by mu rarer is 1 by sin c. Now this critical angle is given for you. Mu denser we don't know, mu rarer assuming like it's vacuum, that's equal to 1 by sin 45. So mu denser is 1 by sin 45 means root 2. So refractive index of the denser medium is root 2, rarer medium is vacuum, that is equal to 1. Once if you know the refractive index, you need to find the velocity of the light in that medium. We can write a formula that refractive index of denser to rarer as velocity of the light in the rarer by velocity of the light in the denser. Mu denser by mu rarer equal to C rarer by C denser. Mu denser is root 2, mu rarer is 1, C rarer is vacuum 3 into 10 power 8. C in the denser medium we have to find out. So C in the denser medium is 3 by root 2 into 10 power 8 meter per second. That is option B is the answer for the problem. That's how we solve these two simple problems. Thank you for watching.